Another way to solve a system of equations besides graphing is to use substitution. What substitution is when you substitute one whole expression into the other equation for the variable that it's equal to. So for example, it says solve x equals y plus 2 and 3x plus y equals 10. So we're going to choose the equation that we're going to use to substitute. Well, if we take a look right here, this already has a y equals x plus 2. So it's already solved for a variable, so that's the one we're going to use. So we're going to solve by substituting the x plus 2 into that y value. So if you see on the first line we have 3x plus y equals 10. On the very next line we have 3x plus, there it is, x plus 2 equals 10. So now that everything is only in x values or an x variable, you can combine your like terms, and now you just have a two-step equation to solve. So I'm going to subtract the 2 from both sides, divide by 4, and I have an x value of x equals 2. Well, there's the x value. So now, continuing with substitution, I'm going to substitute that x equals 2, that 2, back into the original equation that already had the y to find the value of y. So I plug in the 2, and I get y equals 2 plus 2, which is just 4. So the solution is the 0.24. So now we have to see, is the 0.24 truly the solution? Is it the answer? It's the solution to this system of equations. So I go and I substitute in the 2 and the 4 to both equations, not just one, both equations. So for y I'm going to use a 4, and for 2 I'm going to use a 2. Or excuse me, for x I'm going to use the 2. So 4 equals 2 plus 2, does 4 equal 4? Sure enough it does. So then I'm going to go plug in the 2 and the 4 for the x and the y in the other one, and I get 6 plus 4 equals 10. 10 equals 10, so it's an answer. So when we go down here to this one, I see that this x is already solved for. So I'm going to take y minus 1 and I'm going to put it in for this x right here. So I'm going to start with y minus 1 plus 2y equals 8. Now I'm going to combine these two like terms. 3y minus 1 equals 8. Now I'm going to get the y by itself by undoing this minus 1 and this times 3. I have to undo the minus 1 first, so add 1 to both sides. And I get 3y equals 9. I'm going to undo that times 3 using division, so y equals 3. Now that I know y equals 3, I'm going to plug it back in here. So x equals 3 minus 1, x equals 2. So I'm going to now check my work. I'm going to plug in a 2 for the x in the first equation. Let's make sure it's on camera so you can see. Equals, and I'm going to plug in a 3 minus 1. Well, 3 minus 1 is just 2, so that works out. Now I'm going to plug that into the second equation. 2 plus 2 times 3 equals 8. Well, that's 2 plus 6, and I know that 2 plus 6 does equal 8. So the solution to this system is the 0.23. 0.23. Alright, so now I have this equation where both of them are solved for y. They're solved for the exact same variable. So I'm going to substitute this in for that y, and I get x plus 2 equals 2x minus 5. This is an equation that has variables on both sides, so I'm going to put my x's over here, and I'm going to put my numbers over here. So I'm going to subtract x from this side, and then to undo this minus 5, I'm going to add 5 to both sides. And what I see here is that I have minus x plus 5 and minus x plus 5. That tells me that I'm on the right track, because I'm doing the same thing to both sides. So x minus x goes away, 2 plus 5 equals 7. And then I get 2x minus x is just x, and the 5 goes away. So I'm done at this point. I have 7 equals x. So now I'm going to pick an equation. I'm going to plug the 7 back in. So I'm going to have y equals 7 plus 2, or y equals 9. So that's the answer for that one. So let's double check and make sure. So I have 9 equals 7 plus 2, sure enough. And then I'm going to have 9 equals 2 times 7 minus 5. Well, 2 times 7 is 14, minus 5 is 9. That does work. So my point that is the solution to this system of equations is the ordered pair 7, 9. So I've already got y by itself here. I'm going to plug it in. So I get 3x plus x plus 5 equals negative 11. I'm going to combine my like terms, and I get 4x equals, or excuse me, almost forgot my plus 5. Plus 5 equals negative 11. To get the x by itself, I subtract 5 from both sides. Notice I take my signs with me as to help remind me about what I'm doing. And I get 4x equals negative 16. Divide both sides by 4. And I get x equals negative 4. Alright, so now that I know what x equals, I need to figure out what y equals. I'm going to plug that in to this equation, that top equation right there. So I get y equals negative 4 plus 5. Alright, so with that, negative 4 plus 5 is just 1. So x equals negative 4 and y equals 1. So I'm going to plug it in down here to check my work. 1 equals 5 plus negative 4. If you weren't quite sure, you could always grab your calculator and you would see that that works out just fine. And then I can say 3 times negative 4 plus 1 equals 11. Plugging in the negative 4 for x and the 1 for y. This is negative 12 plus 1 equals, excuse me, I almost didn't bring down my negative, negative 11. And that is a true statement, so I know that's correct. So the ordered pair, negative 4, positive 1, is what is the solution to this system. So again, this is a situation where I'm going to substitute in y minus 10 for this x, and I'm going to end up with plus 10 equals 2y plus 3. I'm going to put my letters on the right and my numbers on the left. Only because I have more letters over here, you could certainly go the other way if you wanted to. So I'm going to subtract y to get the letters over here. I'm going to subtract 3. Draw my line, double check, negative y, negative 3, negative y, negative 3. I'm on the right track. That'll cancel. 10 minus 3 is 7. Bring down my equal sign. 2y minus y is just y. So I'm done at that point with the y value. I'm going to plug it back into the x, or for the y to find the x. So I get 7 plus 10, x equals 17. So I'm going to take these two and I'm going to plug it in to both to see if it works. So I get 17 equals 7 plus 10. That does in fact work. And then over here I'm going to do 17 equals 2 times 7 plus 3. Well, that's 17 equals 14 plus 3. 14 plus 3 does in fact equal 17. So my answer is the point 17, 7. As we continue to solve systems by substitution, sometimes we realize that the variable is not already by itself. So we have to make a decision about which variable do we want to get by itself to make it work. The best rule of thumb is to find the variable that is, if it's not already by itself, it is almost by itself. So it's not being multiplied times anything, and maybe worst case scenario, we need to change its sign. So out of these 4 options of x's and y's, this y right here is almost by itself. It's not being multiplied times anything, and it's already positive. So what we're going to do is we're going to get that y by itself. So we're going to solve this equation for y. We end up with y equals x plus 4. At this point, we treat it as if it was this equation and this second equation and do exactly what we were doing on the other side of the page. And you can see all the step-by-steps. We replace the y with the x plus 4. So 2x plus 3 times x plus 4 equals 27. Distributed the 3. Combined their like terms right here. Started subtracting to get that x by itself. So we end up with 5x equals 15. Divide both sides by 5 and you got that x plus 3. Going back, you plug it back in to see what that y value is. So plugging in the 3, you get y equals 7. So your solution is 3, 7. And you've got to plug it back into the 2 original equations, the 2 original not messed with equations to see if it works. And this solution does in fact check out. So we have 2 more problems where we're just going to go ahead and do that. So looking at these 4 options, I have this x that's almost by itself and this y that's almost by itself. Quite frankly, it does not matter which one you pick. I'm just going to pick to change the top one around. So I'm going to add y to both sides, and I get x, and I write the letter y, but x equals y minus 3, because I'm leaving that negative with that 3. I'm going to replace this first x right here with y minus 3. So I'm going to get 2 times y minus 3 plus y equals 12. Distribute my 2. 2y minus 6 plus y equals 12. I'm going to combine my like terms. 3y minus 6 equals 12. Add 6 to both sides to start getting that y by itself. And I'm left with 3y equals 18. Divide both sides by 3, and I get y equals 6. You would have still ended up with y equals 6 even had you gone the other route and gotten this y by itself first. So I'm going to take the 6, I'm going to plug it back in, and I'm going to plug it into this one because then all I have to do is a little bit of math to get that x. So I get x equals 6 minus 3. Well, in that case, x is said to equal 3. So I'm going to check the point 3, 6 to see if it works. So I'm going to plug it into this first one. I get 3 minus 6 equals negative 3. Well, if I plug that into my calculator, 3 minus 6 does in fact equal negative 3, so I know it works. Then I'm going to plug it into the second one. I'm going to get 2 times 3 plus 6 equals 12. So that is 6 plus 6 equals 12. Well, I know that 6 plus 6 does equal 12, so that works. So the answer to this is 3, 6. The point 36 is the solution. So again, over here, out of these 4 options, I get y minus x, or 5x and 2y. This y is almost by itself, so I'm going to get it totally by itself by adding x to both sides, and I get y equals x plus 8, because this becomes positive and the 8 is still positive. I'm going to plug that into this equation right here. So 5x plus 2 times x plus 8 equals 9. I'm going to distribute that 2. 5x plus 2x plus 16 equals 9. Combine like terms. When I subtract 16 from both sides, I get 7x equals negative 7. So I divide both sides by 7, and I get that x equals negative 1. I'm going to plug that negative 1 back into this equation that's almost solved, and I get y equals negative 1 plus 8, or y equals 7. So a quick check to see if the point negative 1, 7 is my answer. And I'm going to say negative 1, whoops, the y came first. 7 minus negative 1 equals 8. Quick check on my calculator, and that's true. Or I can remember that a negative and a negative together is going to be a positive, so 7 plus 1 equals 8. We know that's true. And then we're going to say 5 times negative 1 plus 2 times 7 equals 9. So we're going to say 5 times negative 1 is negative 5 plus 14 equals 9. And that's basically 14 minus 5, or again, you use your calculator to help you out, and you do get, in fact, that 9 equals 9, so that's true. So my answer is the point negative 1, 7. That's the solution to this system of equations.